So now we've got a Linux machine set up. We're going to add some additional stuff to it. So we've got a generic machine. So let's log in again to our machine, this time with our account. Okay. And let's turn on the firewall. We don't want it to just run without a firewall. So any command that we need to run as root now, we have to put sudo before it because we're not logged in as at root anymore. So sudo UFW, which stands for Uncomplicated Firewall.
Isn't that the Iron Workers of America or something?
So we will allow, and there's two options here. We can do 22/TCP, which is the port that SSH runs on, because we definitely want to allow SSH through our firewall before we do this, otherwise we'll brick our machine again. Or the Uncomplicated Firewall actually recognizes the word SSH and knows that means port 22. Either one works. Requires our password. Okay, rules updated. Cool. Sudo uncomplicated firewall show added lets us see the list of rules they've got. So we've got allow port 22. So let's enable it. UFW enable. It gives you a nice big warning. This may disrupt the SSH connections. So you're not going to accidentally break it. So this will give you a nice reminder. Make sure you allow SSH through your firewall. So yes. Okay, firewall is active. And we didn't get logged out or disconnected, so we're good there. So we can look at it too. Sudo uncomplicated firewall status gives us a nice list of everything that's allowed. So we can see here it says from anywhere allow it if it's going to port 22, both normal IP and IPv6.
All right, so you did sudo. Zoom in on that for one more second. Sudo UFW allow SSH, and then it asks you for your password.
Yep.
And it said rules are updated. And then you said UFW show added, and added user rules. See UFW status for running firewall. And then the UFW allow 22 is the rule that was added.
Yes.
Okay.
So the show added. So status will just say status inactive if the firewall is not on. So show added lets you see the rules even if the firewall is not on.
Okay. And then sudo UFW enable turned it on, and it's like, are you sure you want to turn this on? Because you're going to blow out your SSH if you haven't set that already. Mm-hmm. And you say yes.
Yep, and it says firewall is active and enabled on system startup, so you don't have to say enable every time your machine goes down again.
Oh, cool. And then sudo UFW status shows us the status. And so from anywhere, we're allowing connections on port 22.
So if you do status numbered.
What's the V6 part again?
IPv6.
IPv6, thank you.
So if you say UFW status numbered, it'll give you these numbers, and you can delete a command. One of these rules was delete and the number. So I'm not going to do this now on these rules because we really don't want to mess up our SSH rules.
That's totally neat.
So next step is the clock. So if we type date, it tells us it's 14:42 Eastern time.
Which means class is over.
Yeah. So we don't want Eastern time. So we've got this command here, sudo dpackage -reconfigure time zone data. This gives us a really nice graphical menu here. So we can choose America, and then LA is the Pacific time one. Boom. So now when we call date, it tells us it's 11:42 Pacific time, which is correct. Yeah, I don't know how far off that clock is, but
It is correct.
yeah. So next thing we want to do is we should install NTP. NTP is a program which will basically continuously sync our clock. So if our clock gets out of sync for whatever reason, NTP will fix it. So it's a good thing to just have running in the background. So this is the first time we're using a package manager. We need to use, so apt-get is the Ubuntu package manager. We need to run it as root. This is the first time we're doing anything with it. We need to run update on it. Update will make it download all the list of every package that's available and what version it's at. So we need to have that available and where it's located. So we're going to need that all pre-downloaded before we can actually tell it to go install anything. After you run update, you can run upgrade, which will let it update any version, any software on your machine, which is a good idea to do. But we'll skip that for now. So the install command, install something, and we're going to install NTP. So yes, install it. It's downloading, installing, and part of NTP's install scripts is it puts itself into the run on boot area of your computer, so you don't have to worry about it anymore. It's done. NTP is now installed and running. Your machine, so your machine will never get out of sync with the clock, with global time. Let's run that upgrade now, actually. Upgrade. See, look at this. All these packages that are out of date need to be updated. Linux firmware, Cloud Init, dpackage, Python 3, Ubuntu release upgrader. So bunch of packages. Let's let that install while we look ahead. While I describe swap space, which is the next part. So we've got, what was it, 16 gigs of RAM, I think?
Yeah.
So we got 16 gigs of RAM, which is plenty for our purposes. But if you're running some, like the $5 a month machine where you only have half a gig of RAM, you're definitely going to want to swap space. So those of us going through 144, Ming Lee is currently going through how the OS will drop chunks of memory to disk if it needs to, if it runs out of memory. Linux doesn't do that by default. The swap space is where it does that. So we have to configure it ourselves, though. So 16 gigs is plenty for our machine, but let's go over how to do this anyway. So we want to run sudo fallocate, which is file allocate, -L, and we'll give it a size. So recommended sizes are either equal to your RAM or double your RAM. So I think equal to is good enough for us. So 16 gigs. And then a place where we're going to place it. So we're going to place it at /swap file. So done. 16 gigs of our hard drive has now been dumped into a file. So if we go over to root and look at it, we can see it here. Swap file. It's a massive size there. 16 gigs. Owned by root, group root, and these permissions. We don't want it to be read for everyone. This is our extra memory space. What if some application's got your passwords in memory and it gets dumped to this file? We do not want it to be read for everyone. So sudo change mod 600/swap file. So read only, read write for root only. Next up, sudo. So next up, we've got this empty file, basically, the 16 gigabyte empty file on our hard drive. So sudo make swap will configure it so it can be used as a swap file. Boom, is now a swap file. Size 16 gigabytes, or gebibytes, I guess, which is technically, which is the 2 to the 30th power instead of 10 to the 9th. So now it's configured to be a swap file. So we'll sudo swap on swap file. Okay, we're now using it. However, swap on only works once. It means every time our server goes down, we have to run that again, which stinks. So let's add it to this big, long, complicated command here. Lets us add it to on boot. Swap file, none, swap, sw00 /etc/fstab, which is the funniest name for a file. So the fstab file is the list of how Linux builds its file system based off of what hard drives you've got. So we've got multiple hard drives, we've got a bunch of machines. We may have multiple hard drives, we may have CD drives. So fstab tells Linux how to set that up on boot.
All right, so hold on one sec, I got a question. Sudo sh is shell?
So yeah, sh counts as shell. So we're basically running whatever the default shell is, with -c is for command. So whatever the next argument is the command that shell is going to run.
Okay.
So then echo just repeats whatever its argument is. So we give this this line here in quotation marks. Greater than says whatever this previous program is printing to the command line, instead put it at the end of the file after this. So /etc/fstab.
You can read it as pipe 2.
Yeah.
And it's append, which is different than just greater than, which would overwrite and just.
Yeah, don't use a single greater than. You will overwrite that, and then you will not be able to boot your machine anymore because it won't know where your hard drive is.
And
So,
fstab gets run on
boot.
On boot, okay.
Yep. So if we look at our fstab file, so yeah, fstab file is the list of how Linux builds its file system based off of what hard drives you've got. So we've got multiple hard drives, we've got a bunch of machines. We may have multiple hard drives, we may have CD drives. So fstab tells Linux how to set that up on boot. So we can see how it's setting up our drive. So first off, it's got this UUID, which is the hard drive that the machine's got. It says it's going to be mounted at /. It's an ext forward file system, which is the default Linux. On an error, it'll remount it as read-only, and then 01 for dump and pass, which I'm not actually sure. It's also got /dev/fd0, which is a floppy drive. It's going to mount that at /media/floppy0, and that'll be a floppy drive. I don't know why they've got a floppy drive on their machine at the end, but they do. And then here's our line that we added. So it's going to look for /swap file in our file system. It's not going to mount it to anywhere, but it's a swap type, and options is SW for swap, and then 00 for dump and pass, which I'm still not sure what those are.
Nice, man.
So on boot, it'll create our file system. Does first as the first line, which creates our main thing. Then it checks it. Now it's got the file system, so it can look in /swap file to find where that file is and use it as a swap file. And
then you mentioned just briefly here the GIB versus GB. GIB is 16 gigabyte.
Okay, yeah, GB is gigabyte, which is 10 to the 9th power, I believe.
Mm-hmm.
And then GIB is gebibyte, which is 2 to the 30th power,
so it's like
which is more technical.
That's the difference between a kilobyte's 1,000 bytes or a kilobyte's 1,024 bytes.
Yes.
Right? Okay.
So
GIB is the one with the 24, so to speak.
Yeah. Right. So right now this is a perfectly running Linux server now. We've got the swap file, we've got time, we've got firewall. This is a really good point to save a snapshot that we can restore from for when we want to set up a machine from now on. So to do that, we sudo power off. That'll disconnect us. Go back to our DigitalOcean thing. Go to snapshots over here on the left. Then we need to keep refreshing the page until it tells us the machine's off. It's going to this. Okay, machine's off. We'll give it a name. We'll just call it a test server
class.
Config. Yeah, class.
That's what we did in class.
So take snapshot. Just take a minute. It basically creates a copy of your hard drive that you can restore from in the future. So this is really good for if we want to have like one machine for our Go server and one machine for our database. We can just start from this template and have the one that we install Go on and the one that we put our database on. But we've got all this initial config all ready and set up. So next up is configuring Go. So this is a good point to stop the video, I think.